Okay, so I was insisting on like a parachute fail-safe recovery system. So I already have a guided parachute delivery system here. So basically, this thing will steer itself and everything like that. We're not looking for all that capability. We're gonna stick with the same hardware. So APM 2.8, 7.4 volt lithium-ion battery. Um, we're gonna keep the power supply, even though it's overdone for what, because we don't have any motors or anything like that. Neo 6M, and then the transmitter and everything like that, a transceiver. But I have a profile in RD Pilot. Okay, so when I was early development of this, I was just looking to get the parachute to recover itself. There's no cutaway, so there's no secondary chute. There's another chute that pulls it out of the pouch at the back here. That's this canister here. But there's no like secondary chute or anything like that. So, and the key to this was safety after what happened with the pallet size load and that poor African family of 13 in that hut. So this was the earlier stuff was just to be able to tweak the parachute so it opens or untangles or whatever like that. And this is basically the rig we came up with, and it has to be set up in a certain way. And then you can see down here as well. And it's a acrobatic kite. So, but we fly it at an angle like this, and it slows descent, but it allows for good spiraling patterns, even in the face of crosswinds and everything like that. So basically, I'm going to use the same RD Pilot profile. So this actually right now has the glider, but it has that. We have that basically. Specific. So all it does is try to keep the parachute open or get the parachute open based on what it's sensing and how it feels with its its gyroaccelerometer and its descent and everything like that. So, and then the machinery itself, I can pare it down to just one servo, but it has to be a pretty strong servo, and then a little bit of a strain relief system. This is the earlier version of this. The finalized like prototypes or whatever like that, they ended up sold and fielded, but I never got any production out of it. But I have the ability, so this will be the parachute safety subsystem, safe descent system and everything like that. So the key is here too is that like we're looking to build the airframe itself doesn't have anything flammable, or like there's some small lithium-ion batteries, but they shouldn't burst into flames based on what we're doing, and there's no fuel. It's a mechanically driven aircraft. So the other thing is about that, because of the stresses and because of how strong the frame itself has to be for the takeoff process on the rail or the slingshot or tower, however we're going to do it. It makes it like a good falling object that could do damage, because it's got rigidity to it, and whatever it hits, even though it's not going to burst into flames, explode, or anything like that, it could do some damage. So the key is here is to the parachute safety subsystem, and then I'm thinking about some kind of airbag, like an inflating, maybe possibly some type of gas system, or the other option is as we get larger and we're going to be at higher altitudes, possibility of a cartridge-based, it's a weather balloon. So, a large latex weather balloon. We would have to do some kind of netting over it, and it would have an expiration date on it. But as you got into larger loads, so say we're at 10 pounds, say we started going up to 100 pounds, maybe 1,000 pounds, we're flying at 10,000 feet, 30,000 feet, whatever it is. It loses power, it has some issue, whatever, it's going to try to glide as much as possible, but this is another option. It's a weather balloon. We can carry enough on board, whether it's a cartridge or a small tank and a heating element, or a gas conditioning element, so we have some ability to control the temperature of the gas as it exits. And then the other option is a chemical reaction where we have both sides of it on board, and in some kind of a controlled mechanical mixing. I'm not sure, like some kind of automated mixing method. I think probably the cartridge, gas-based option is probably going to be the better way to go. And this is a long shot. We're going to be looking to take advantage of airfoils, parachute systems, and I've got the existing technology to just kind of bolt it on. Now, the other option is that we pare it down, and we just go with Neo 6M GPS, and then just a gyro accelerometer, 3-axis gyro accelerometer, and like an Arduino, and then like similar to what we have here with the ongoing effect module, but not as much. We wouldn't need the solar on it. We wouldn't need the acoustic stuff or anything like that. So that's kind of where we're at. It's kind of already put to bed. It's just about finding space for it and rigging it to the frame. But the best hard points. I'm thinking the top of the struts. Like where the winglets connect to the upper wing. So where that strut ends up, or possibly the tension wire attachment points that are in between the wing, like at the other part of the structure that attaches to the winglet. The wire. If you look at the diagrams, you'll see it. One of the two spaces, and then the pouch gets folded into a compartment that like kind of sits flush, and the chute that opens up everything, kind of popped up, and then some kind of mechanically actuated. It just has to be squeezed, or some kind of like explosive bolt or whatever, something that makes it pop out. Thank you.